Turkey has long relied on fighter jets made by other countries, especially the American F-16. For many years, these planes have been the backbone of the Turkish Air Force, protecting the nation's skies and serving its interests. However, as technology moves forward, older planes need to be replaced. Turkey realized it needed a modern next-generation fighter to keep up with the world. This new plane would need to be stealthy, meaning it is hard for enemy radar to see. It would also need advanced computers and weapons to handle future threats. This need became much more urgent after Turkey was removed from the F-35 program, a project led by the United States to build the world's most advanced fighter jet. This event pushed Turkey to speed up its own plans. The answer to this challenge is the KAAN fighter jet program. Launched over a decade ago, the project's main goal is to give Turkey strategic independence. This means Turkey wants to be able to design, build, and maintain its own military aircraft without needing permission from other countries. By creating KAAN, Turkey aims to join a very small group of nations that can produce their own fifth-generation stealth fighters. These countries include the United States, Russia, and China. Having its own advanced jet gives Turkey more control over its defense policies and allows it to protect its interests without relying on foreign suppliers who might have different political goals or impose restrictions. The KAAN project is more than just about building a single airplane. It is about building a whole new future for Turkey's aerospace and defense industry. The plan is to create a fighter that is powerful, smart, and adaptable. The jet is designed to have features like supercruise, which allows it to fly faster than the speed of sound for long periods, without using extra fuel. It will also have sophisticated sensors that work together to give the pilot a complete picture of the battlefield. The Turkish government and its main defense company, Turkish Aerospace Industries, envision KAAN not just for their own air force, but also as a product to sell to other friendly nations around the world. This ambitious journey began with a clear vision: to create a national combat aircraft that could meet all of Turkey's security needs for decades to come. The program, once known as TFX, was renamed KAAN, which means ruler or king, a name that reflects the high hopes Turkey has for this aircraft. From the very beginning, the project was seen as a symbol of national pride and technological achievement. It represents a major step for Turkey in becoming a self-sufficient military power. The development of KAAN is a long and expensive process, full of challenges, but for Turkey, the goal of having its own advanced fighter jet is worth the effort and investment. The journey to build a new fighter jet always begins with a first model, known as a prototype. For the KAAN program, this first aircraft, called Prototype 0 or P0, was a major milestone. Its creation was a massive effort involving thousands of engineers and technicians at Turkish Aerospace Industries. They worked day and night to turn complex computer designs into a real physical aircraft. The prototype was officially shown to the public in March 2023, a proud moment for Turkey. This was the first time the world could see the shape and size of the new jet. It had a sleek, modern design with two powerful engines, a large wingspan, and features that hinted at its stealth capabilities. After its public debut, the team prepared the first prototype for its most important test, its maiden flight. This involved months of ground tests, where every system on the aircraft was checked and rechecked. The engines were fired up, the landing gear was tested, and the flight controls were moved to make sure everything worked perfectly on the ground before attempting to fly. The engines chosen for this first prototype were General Electric F-110 engines, the same type used in some F-16 jets. Using a proven engine helped reduce the risks for the initial flight tests, allowing the team to focus on how the new airframe performed in the air. The big day arrived on February 21st, 2024. The KAAN prototype took off from an airfield in Ankara and successfully completed its first flight. The flight was short, lasting about 13 minutes, but it was a huge success. During this time, the jet flew to an altitude of 8,000 feet and reached a speed of about 230 knots. For the test pilot and the entire team on the ground, these moments were filled with both excitement and tension. The main goal was simple: to prove that the aircraft could take off, fly safely, and land. The successful landing was met with cheers and celebration, as it marked Turkey's official entry into the club of nations capable of flying their own advanced fighter. This first flight was just the beginning of a long testing phase. A few months later, in May 2024, the prototype flew again, this time reaching a higher altitude of 10,000 feet. Each flight provided valuable information to the engineers. They collected data on how the aircraft handled, how the engines performed, and how the different systems worked together in the air. Later in the year, tests were conducted to fire up the engine's afterburners, which provide a huge burst of extra power. These early flights were not about pushing the jet to its limits. They were about carefully and safely learning what the first design could do and what needed to be improved for the future. The first flights of the KAAN prototype were a great success, but they also served a very important purpose: to find problems. In aerospace engineering, no first design is ever perfect. Flight tests are designed to reveal weaknesses, so they can be fixed in later versions. The data collected from Prototype Zero's flights gave engineers a real-world look at their creation. They discovered that the aircraft had some issues with aerodynamic drag. This means that the shape of the plane created more resistance from the air than they wanted, which can make the jet slower and less fuel efficient. It is a common problem in new aircraft designs, and finding it early was a positive outcome. Another key lesson learned was related to the aircraft's weight. The first prototype was heavier than the ideal target weight. In a fighter jet, every extra pound matters. A lighter aircraft can fly faster, turn more sharply, and carry more fuel or weapons. The engineering team had to find ways to make the plane lighter without making it weaker. This challenge pushed them to look at new materials and different manufacturing techniques. The structural strength of the airframe was also carefully studied. Engineers needed to be sure that the plane could handle the extreme forces of high-speed flight and sharp maneuvers in combat. The initial design of the first prototype was primarily a technology demonstrator. Its main job was to prove that the basic concept of the KAAN was sound and that Turkey could build an aircraft of this complexity. It was not intended to be the final version that would enter military service. Think of it as a first draft of a book. It has the main story, but it needs a lot of editing and rewriting to become a masterpiece. The lessons learned from Prototype Zero were like the editor's notes, telling the designers exactly what needed to be changed to make the aircraft better, stronger, and more capable in its future versions. These findings were not seen as failures but as crucial steps in the right direction. Every challenge identified was an opportunity for improvement. The team at Turkish Aerospace Industries took all the data from the flights and ground tests and began working on a major redesign. They now knew where the plane's structure needed to be reinforced, where weight could be saved, and how the shape could be refined to slice through the air more efficiently. This process of learning and adapting is at the heart of developing any advanced technology, and for the KAAN program, it set the stage for a much improved second prototype. Following the valuable lessons learned from the first prototype, the Turkish design team immediately began working on the second model, known as Prototype 1 or P1. This was not just another copy of the first plane, it was a significant redesign from the ground up. The goal was to create a version that was much closer to the final production aircraft. The second prototype, which is currently being assembled, incorporates major changes to address the issues of drag, weight, and structural performance identified during the initial flight tests. It represents a big leap forward in the KAAN's development, moving from a basic demonstrator to a more mature and refined pre-production platform. One of the most noticeable changes in the second prototype is its physical size. The new airframe is slightly smaller and more compact. Its length has been reduced to about 20.3 meters, and its wingspan is now around 13.4 meters. This smaller profile helps in several ways. First, it makes the aircraft more agile, allowing it to turn and maneuver more quickly in the air. Second, a smaller surface area helps reduce the aircraft's radar cross-section, which is a key part of making it stealthy and harder for enemies to detect. The overall shape has been refined to be more aerodynamic, directly addressing the drag issues found in the first prototype. Another important change can be seen at the front and sides of the aircraft. The nose of the second prototype has been made wider. This is not just for looks, it creates more space inside for advanced electronics, such as a powerful new radar and an infrared search and track system. An IRST system allows the jet to find and track enemy aircraft by their heat signature, which is a stealthy way to operate without using its own radar. The engine intakes, the openings that feed air to the engines, have also been redesigned. They are now taller and have been moved to a new position to provide better airflow, which is critical for achieving supercruise and getting the most power from the engines. To tackle the weight problem, the second prototype uses more advanced materials. The engineers have increased the use of lightweight carbon composites and special thermoplastics throughout the aircraft's structure. These materials are incredibly strong, but weigh much less than traditional metals like aluminum or titanium. By using them more extensively, the team has been able to reduce the overall weight of the aircraft, while at the same time reinforcing critical areas to make the structure more robust. These changes are vital for ensuring the final KAAN jet will meet its performance targets for speed, maneuverability, and durability in a real combat environment. When you place the first and second KAAN prototypes side by side, the differences become very clear, even to an untrained eye. The first prototype, P0, was a pathfinder. It was built to be big and robust, with a design focused on getting a new airframe into the sky safely. Its dimensions were larger, with a length of 21 meters and a wingspan of 14 meters. It served its purpose perfectly as a learning tool, a physical model that could be tested and studied. Its design was based on initial calculations and simulations, but the real world of flight revealed where those calculations needed to be adjusted. It was the rough sketch that laid the foundation for the final artwork. In contrast, the second prototype, P1, is all about refinement and optimization. It is visibly sleeker and more compact, having been trimmed down in length, wingspan, and height. This new, smaller form is a direct result of the flight test data from P0. The engineers learned that a more compact design would provide better agility and stealth. Think of it like the difference between a big, powerful muscle car and a nimble, high-tech sports car. While both are fast, the sports car is designed for superior handling and efficiency, which is exactly what a modern fighter jet needs. The second prototype is the result of sharpening the pencil and drawing cleaner, more precise lines. The functional differences are even more significant than the visual ones. The first prototype was a demonstrator, equipped with the basic systems needed to fly. The second prototype, however, is being built as a pre-production model. This means it is designed to carry the actual mission systems and avionics that the final jet will use. Its wider nose is not just a shape change. It is a dedicated space for the advanced AESA radar and other sensors that will give the pilot superior battlefield awareness. The redesigned engine intakes are not just cosmetic. They are engineered to feed the engine's air more efficiently, a critical step toward enabling the jet to supercruise. Ultimately, the first prototype was about asking questions, while the second prototype is about providing answers. P0 asked, "Can we build and fly a stealthy-looking jet?" The answer was yes. P1 asks, "Can we build a jet that meets the strict performance requirements of a fifth-generation fighter?" The changes made, reducing weight with composites, improving airflow to the engines, and creating space for advanced systems, are all intended to make that answer a firm yes. The evolution from the first to the second prototype shows a program that is learning, adapting, and maturing rapidly on its way to creating an effective and combat-ready aircraft. The KAAN project is not just changing Turkey's air force, it is also changing how Turkey is seen on the world stage. For decades, Turkey has been a key member of the NATO alliance, a partnership of Western countries led by the United States. As a NATO member, Turkey's military has often used American and European equipment. However, by developing its own advanced fighter jet, Turkey is signaling a desire for greater self-reliance. This reduces its dependence on the United States for critical defense technology, like the F-35 fighter jet. This shift gives Turkey more freedom to act on its own and increases its bargaining power within the alliance. This pursuit of independence has created some tension with the United States. Turkey's decision to buy the Russian S-400 air defense system led to its removal from the F-35 program and to US sanctions. More recently, in September 2025, it was reported that the US Congress was holding up the sale of the American-made F-110 engines needed for the first batch of production KAAN jets. This engine block highlights the complicated relationship between the two allies. While Turkey officially states there are no delays to the program, it also shows why developing its own engine is a top priority to avoid being dependent on foreign political decisions. Beyond its relationship with the West, the KAAN jet gives Turkey a powerful new tool for foreign policy. If successful, KAAN could become one of the only fifth-generation stealth fighters on the export market that is not made by the United States, Russia, or China. This creates a new option for countries that may not be able to buy the American F-35 due to political reasons or cost. Turkey is already positioning KAAN as an attractive choice for nations in the Middle East, Asia, and Africa. By offering to sell this advanced technology, Turkey can build stronger alliances and increase its influence in these regions. Potential customers are already showing interest. Countries like Azerbaijan and Pakistan, which have close ties with Turkey, are seen as likely buyers. In a significant development in July 2025, Indonesia signed a preliminary agreement to potentially buy dozens of KAAN jets in a deal that could include technology transfer. While such deals are not yet final, they show the strong global interest in the project. By becoming an exporter of high-tech fighter jets, Turkey would not only gain economically, but also solidify its position as a major regional power and a key player in the global defense market, challenging the long-standing dominance of traditional arms suppliers. The journey for the KAAN fighter jet is still in its early stages, with a long and challenging road ahead. The current plan is for the first KAAN jets to enter service with the Turkish Air Force sometime between 2028 and 2030. To get there, the program will continue with a series of prototypes. After the redesigned second prototype, at least 4 more are planned to fly. Each new prototype will test different systems and flight capabilities, gradually pushing the aircraft closer to its final performance goals. These goals include reaching a top speed of Mach 1.8, being able to withstand extreme G-forces in dogfights, and carrying a full load of weapons. One of the biggest challenges for the program is the engine. The first prototypes are flying with American-made General Electric F-110 engines. However, as recent political tensions have shown, relying on a foreign supplier for such a critical component is a major risk. To solve this problem, Turkey is working hard to develop its own jet engine. A Turkish company, TEI, is developing a powerful engine called the TF-35000. The goal is to begin ground tests of this new engine in 2026 and to have it ready to be installed in all production KAAN jets by the early 2030s. Achieving this will be a massive technological accomplishment and will give Turkey true independence. As the development continues, Turkey is also looking to sell the KAAN to other countries. The export market is a key part of the program's long-term strategy. Export sales would help lower the cost of the jet for Turkey's own air force by increasing the number of planes being produced. Turkey is promoting KAAN as a capable and more affordable alternative to other fifth-generation fighters. The recent preliminary agreement with Indonesia is a promising sign, and Turkey hopes to secure more partners and customers in the coming years. For export versions, Turkey has stated it plans to use its own domestically produced engines, making the offer even more attractive to nations wanting to avoid reliance on the US. Looking even further into the future, the KAAN is being designed to be adaptable. Its advanced computer systems will allow for easy upgrades as new technologies become available. One of the most exciting future capabilities is manned-unmanned teaming, or MUM-T. This means a KAAN pilot will be able to control a team of unmanned, loyal wingman drones from the cockpit. These drones could fly ahead to scout, jam enemy radars, or even carry extra weapons, acting as a force multiplier for the piloted jet. This forward-looking design ensures that the KAAN will remain a modern and effective fighter for many decades. The KAAN fighter jet program is far more than just a military project for Turkey. It is a powerful symbol of the nation's ambition and a critical part of its strategy for the 21st century. Born from the need to replace an aging air force and accelerated by geopolitical events, KAAN represents Turkey's determined push for self-sufficiency in defense. By undertaking this complex challenge, Turkey aims to secure its skies with its own technology, free from the political pressures and supply chain risks that come with relying on other nations. This quest for strategic autonomy is reshaping Turkey's role within NATO and its relationships across the globe. The development journey, from the first flight of the initial prototype to the advanced redesign of the second, shows a program that is learning and evolving. Each challenge, whether it is excess drag weight issues or engine supply hurdles, has been met with innovative solutions from Turkey's growing defense industry. This process is not only creating a capable fifth-generation fighter, but is also building a foundation of knowledge, skill, and industrial capacity that will benefit the country for generations. The project is fueling a technological revolution within Turkey, lifting up hundreds of local companies and creating a new generation of engineers and scientists. For the rest of the world, the arrival of KAAN signals a shift in the global defense market. It introduces a new and credible competitor from a non-Western power, offering an alternative for nations seeking advanced military hardware without the political strings often attached to American, Russian, or Chinese equipment. If Turkey succeeds in both producing the jet for its own needs and exporting it to others, it will solidify its status as a major regional power with global influence. The KAAN jet is a tool that could help Turkey build new alliances and project its power in a way that was not possible before. In summary, the KAAN program is a defining national endeavor for Turkey. It is a test of its technological prowess, its industrial strength, and its political will. The success of this aircraft will determine the future of the Turkish Air Force, the direction of its foreign policy, and its place in the world. While the road ahead is long and filled with obstacles, the progress made so far demonstrates a clear commitment to the goal. The KAAN is not just an airplane. It is the embodiment of a nation's aspiration to control its own destiny and fly into the future on its own wings.